Hi students, how are you? Welcome to today's topic, real numbers part 2. Before going to the class, in previous class we have studied about number system. In that, what are the natural numbers, whole numbers, integers, rational numbers and irrational numbers. Okay, what are the natural numbers in that? We see what are the rational numbers. Rational numbers, the numbers. Rational numbers denoted by Q, the numbers which can be expressed in the form of P by Q, where Q is not equal to 0 and P, Q are integers, are called rational numbers. Yes. And what are the irrational numbers? Which are not in the range, which cannot be written or which cannot be expressed, which cannot be expressed in the form of P by Q. Yes, we studied in previous class. And the collection of rational and irrational numbers together is called real number set. Yes. And also we discussed the fundamental theorem of arithmetic. What did he says? Every composite number can be expressed as product of primes, and also the factorization is unique irrespective of the order. And in previous classes we, for example, I have taken 18. It can be written as 2 into 3 into 3. Whether you have seen in your previous classes such type of problems? Yes. You have studied already in the lower classes. In that case, what do you call this method? What did you call this method? Is there any certain name to this method? What are these 2 and 3 are the factors? What type of factors? These are prime factors. Is there any other name to this? Yes. This is called the prime factorization method. Yes. This method is called the prime factorization method. Now today's class, in this today's class, we will learn about finding the HCF and LCM of 2 or more numbers by using prime factorization method. Okay. Today our topic is HCF and LCM using prime factorization method. Okay. Already we have learned in previous classes. Let us recall with some examples. Okay. For example, if I find the HCF and LCM of take 36 and 54. You can take any example. Find HCF and LCM of 36, 54. First, you factorize, write the prime factorization of 36. Outright, it is even number, obviously it is divisible by 2. So 2 into 18. 2 into 18 can be written as 2 into 9. 2 into 2. We can't write more than 2 can be written as only 2 itself. We can't factorize it again. Yes, because it is a prime number. 9 can be written as 3 into 3. Yes. Now it can be expressed as in the exponential form or not. It is 2 into 2. 2 square into 3 square. 2 square into 3 square. It is about 36. Now, what is another number? 54. What is another number? 54. 54 can be written as 2 into 27. Yes. And also 27. 27 can be factorized like this. 3 9 are. Of course, 2 into 3 into 9 can be written as 3 into 3. If you write this prime factorization exponential form, it can be written as like this: 2 power 1 into 3 cube. Now, how to find HCF of 36, 54? If we have expressed 36 and 54 in the form of prime factorization. Okay. How to find HCF and HCF of 36 comma 54? As it is easy. How we have see HCF in the sense we know what is HCF, meaning highest common factor. Now in these prime factorization expansions, what is the common factors in both cases, in both 36 and 54? Here is a common factor 2, here also common prime number 2, here 3 and 3. Now how many factors are common? Here 2 is 2 times multiplied, here 2 is multiplied 1 time. So how many times it is common? Only 1 time. But in that highest we want. So in this case, if you want to write, we have to follow that the product of common factors. Product of what type of common factors we have to take? Smallest common factors. Because here 2 multiplied itself 2 times, but here is 1 time. So common only 1 time. So the product of smallest power of common factors in the given numbers. Here in 2 power 2 and 2 power 1, which one is the least power? 2 power 1. It has 2 power 1. In 3 square and 3 cube, the least power of the prime factor is 3. So that in this 36 is there. So that write into 3 power 2. That means here the HCF of two numbers can be written as product of smallest power of common factors of the given numbers. How to find LCM? LCM of 36 comma 54. LCM of 36 comma 54. In HCF what we have taken? Smallest power of common factors of the given numbers. But in LCM we have to take greatest power of product of the greatest power of the greatest power of the factors of the given numbers. Yes, what is the greatest power in these two? Common factors are here 2 is there. In that 2 power 2 having greatest power. In 3 square and 3 cube, here power 3 is greatest power than 2, so that we consider 3 cube. Yes, this is the answer. That means 2 power 1 into 3 square can be written as 18. 3 cube into, that means 2 square value 4 into 3 cube value 3 into 3 into 3. How much? 27. Now 27 4 jar. How much, Nana? 4 27 jar 108. 4 27 jar 108. Like this we can find HCF and LCM of two positive integers. Now, can you observe any relation between 36 and 54, between the HCF of the two numbers and their product? See here. Here see prime factorization of 36 and prime factorization of 54, and we found the HCF of 36 comma 54 as product of smallest powers of common factors of the given numbers while finding HCF. But while finding LCM, product of greatest power of factors of the given numbers. Greatest power of the factors of the given numbers. Here I am not saying that common factors of the given numbers. Yes, in while finding the least common multiple, I am not saying common factors. But in highest common factors, I am saying that common factors what? Okay. Now relation. See, just find the product of, if you assume 36 as A and 54 as B, find the product of these two numbers. 36 into 54. 36 into 54. Find out fast. How much you are getting? Product. We are getting 1944. Yes. Now see. Now we found already the HCF of these two numbers. What are those? 36 comma 54. Sorry. 36 comma 54. How much we got? 18. We find the product of HCF of these two numbers. HCF of, LCM of 36 comma 54. Now see, their HCF is 18, their LCM is 108. Now find the product. 18 8 are 144, 18 0 are 0, 4 again, 18 1 are 1 plus 1, 1940. Now what do you observe from these two values? Are these same? Yes. So from this what can you write? Therefore HCF of two numbers 36 into HCF of 36 54 into LCM of these two numbers is equal to product of those numbers. Product of these numbers, that means product of two numbers is equal to product of their LCM and HCF. If you want to generalize, we can write it as HCF of A comma B into LCM of A comma B is equal to A into B. This is one relation among the given numbers and their HCF and LCM. By using this formula, if you know the HCF of the two numbers, we can find their LCM, or if you know the LCM of these two numbers, we can find the HCF. Yes? Okay. Students, in this problem we have taken only two numbers, two positive numbers, we found their LCM and HCF. Yes? Now if we take three numbers, three positive integers, how to find? Of course, same method. See, first prime factorization of 12. This 12 can be expressed as 2 into 6, 2 into 3, 3 1 are 3. So 12 can be written as 2 into 2 into 3, that is equal to 2 square into 3 power 1. This is the prime factorization of 12. Now 18. We can do in this method also. This is called PRIME method. Yes, we know already. 2 9 are 18, 3 3 are 1, 3 1 are 3. So find the product of the left hand side factors. Yes, find the product of the left hand side factors. So 18 is equal to 2 into 3 into 3. This can be expressed in exponential form like this: 2 power 1 into 3 square. It is the prime factorization of 18. And what is third number? Third positive integer, that is 24. This can be expressed 2 12 jar, 2 6 jar, 2 3 jar. So what is the prime factorization of 24? 2 into 2 into 2 into 3. Here 2 multiplied itself 3 times, so it can be written as 2 cube into 3 power 1. Now we have to find the HCF and LCM of these three numbers. Okay. Now how? See, HCF of the given numbers. HCF of the given numbers is equal to, already we discussed, what is the product of the smallest power of common factors of the given numbers. First, what are the common factors in this? Two common factor. In this, which is the smallest power? Here is power 2, 1, 3, which is the smallest power 1. So write 2 power 1. Product we are saying, so into. In this 3, here 3 square, here 3 power 1. Here also 3 common factor, which is the smallest power in that? 3 power 1. So 3 power 1, that is equal to how much? 2 3 is 6. So their HCF is 6. Now find the LCM. LCM of the given numbers. What is the LCM? What is the definition? Product of the greatest power of factors of the given numbers. I am not saying common factors. Now here, what is the greatest power? In this 2 power 2, 2 power 1, 2 power 3, which has the greatest power 2 cube. So 2 power 3 into, in 3 power 1, 3 power 2, 3 power 1, which is greatest power, which factor has greatest power? In this 18, we have 3 square, so 3 square. 2 cube value 8, 3 square value 3 3 is 9, 8 9 is 72. This is the LCM of the given number 72. Okay. Now we will see whether previous rule is applicable or not for this. In previous example, HCF of two positive integers and LCM of two positive, if you multiply, it is equal to product of the given numbers. Whether it is satisfying in three numbers, three positive integers case, we are checking. Yes. What is our example? 12, 18 and 24. Find their product. If you consider these as the ABC, then their product is 5184 I got. Yes. You also multiply and check. Now I found the product of their LCM and HCF. We are getting here 6 into 72. The HCF of those numbers is 6 and their LCM is 72. 6 into 72 is 432. Are these equal? These are not same. Not same. Yes, that means in the case of three positive integers, the product of three numbers is not equal to the product of their HCF and LCM. So it is always not possible in this case. But in the case of two positive integers, it is possible. So HCF of three positive integers and LCM of three positive integers, their product is not equal to product of the given numbers. Is always not equal to, you can say that it is always not always may not be equal to. It always may not be equal. So this is the example for finding HCF and LCM of three numbers, and this rule, the rule is not following here. Yes. So till now we have learnt finding HCF and LCM of two and three positive numbers. If you observe those in those examples, in our prime factorization, in their prime factorization, each number have same common factors, irrespective of their powers, irrespective of their number of common factors, but they have common factors. For example, in 3654, the common factors are like 2 and 3. In second example also, we have common prime factors as 2 and 3 only. In next video, we will take some other examples to give more clarity regarding HCF and LCM of some positive integers. Okay.